Here's a nice counting problem. That's number 27. So we're given that Eric has employees that do all this stuff right here, right? We've got all these numbers here. And then we're asked some questions. So we're going to do this with a Venn diagram. So let's start off by writing, you know what, I'm going to write this one pretty big here. So we'll write our universal set. And there's three things going on here. People can cut trees, right? So let's put T for trees. Then there's people who can climb poles. How about P for poles? And then there's people here who can cut wire. How about W for wire? Now, here's what we're going to do. We're going to fill each one of these regions in, right? How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8 regions, and we're going to fill them in with the proper numbers, and we're going to do so by looking at the last number here and then work our way up. So here's what we know. There's 11 people who can do all three. Now all three, that's right in here. So we know that there's 11 people that go into that region right there. These are people who can do all three. They can cut trees, climb poles, and splice wires. Now the next one up the list is this one here. 28 people can cut trees and climb poles. Now cutting trees and climbing poles, that's here, right? You're in trees and poles. So this is, right, you're in trees and you're in poles. So trees and poles is this region right here. And we know that there's 28 people in here. But look, we've already accounted for 11. So the number of people that are going to this region right here is going to be 28 minus 11, which is going to give us 17. Now let's work our way up one more. There's 25 who can cut trees and splice wire. Now here's trees, here's wire, and we've got 25 people in both, right? There's 25 in trees and wire, but we've already counted for 11, so the number in this region right here is going to be 25 minus the 11 we've already accounted for. So this is going to be 25 minus 11, which is going to be 14. And now let's just work our way up again. So 20 can climb poles and splice wires. So poles and wires, we've got 20 in there. So here's poles, here's wires. We've got 20, here's poles and wires. Now we've got 20 people in here. We've already counted for 11. So the number in this region right here is going to be 20 minus 11. So there's 20 minus 11 here. That'll leave us with 9. And then working our way up again, we have 57 in splice wire. So 57 in wire. So now in wire, there's 57 altogether, and we've already accounted for 14 here, 11 here, and 9 here. So the number in this group right here is going to be 57 minus the 14, right? 57 minus the 14, minus the 11, and then minus the 9, and that's going to give us 23. And moving up again, we're up here, 50 can climb poles. So here's the people who can climb poles, and we know there's 50 people in here, but we've already counted for 17 and 11 and 9 of them. So in this region right here, these are the people who can only climb poles. That's going to be 50 minus, 50 minus the 17, minus the 11, minus the 9. So 50 minus 17, minus 11, minus 9, and that gives us 13. And then finally up this last one here, 45 can cut trees. Now here's trees. There's 45 people in this group right here, but we've already counted for 14, 11, and 17 of them. So in this region right here, people who can only cut trees is going to be 45 minus, minus the 14, minus the 11, right? 45 minus the 14, minus the 11, minus the 17. So 45 minus 11, minus 14, minus 17, and that comes out to 3 people. And then finally, we have this group of people out here that can do none of those things. So let's take a look at what we have here. Back over here it says we have 100 people all together. right? So in this entire group, there's 100 people. So let's start counting the number out here. We've already got a bunch of them counted for, right, all over here. So what we're going to have is 100 minus, okay, minus the 3, minus the 17, minus the 13, let's see, where are we? Minus the 14, minus the 11, minus the 9, minus, and I think finally we've got it, that 23. See if we can get it to right here, 23. So I count that to be 10. So let me just circle these so I can see what we have here. We've got 11 in here. Those can do all three. We've got 3 here, 17 here, 13 in that group, 14 over here, 9 there, 23 here, and 10 out here. Now, let's try to answer some of these questions. Here's A. A, what we're looking for is the number of people who can only climb poles and splice wire. Okay, climb poles and splice wire, but not climb trees. All right, or cut trees. So we want poles and splice wire. So here's poles, here's wire, and we want the number in that group, poles and wire. That's 9. Now, the 11 is not included, right, because they can, these people in here can climb poles and wire, but they can also do something else, right? They can also climb trees. And we just want them only in this group here, poles and wire. So we're going to claim that that is 9. Now let's go to B here. So in B, what we're looking for is can do none of these. All right, well, none of these, that's out here, right? That's none. You can't be anywhere inside here. That's outside the union of all of these, and that's going to be our 10. And in part C, all right, part C is can do at least 2. Now look, here's that at least. So the way I like to do these is this. I'm going to write at least 2, and here's the way I can get at least 2. There's 3 things altogether, so to get at least 2, turn them into exactly. So to get at least 2, you can get exactly 2, or, which is a plus, you can get exactly 3. So here's the ways you can get exactly 2. So follow it up here. Here's exactly 2, right? In this group right here, there's exactly 2, these 2, cutting trees and splicing wire. Over here, climbing poles and splicing wire. And here, cutting trees and climbing poles. So this group, and this group. So what we're going to get here, exactly 2, is going to be 14 plus 17 plus 9, and then plus, right, that plus sign there, exactly 3, and exactly 3, that's the one in the middle right here. So that's going to be the 11. And let's see, when we add these up, I got 51. And then let's see, where are we? C, D, can do at most 1. All right, so let's write that like we did the at least 2. So this is D, and what we're looking for here is at most 1. And to get at most 1, when you have these at most or at least, break them into exactly. So how about at most 1 means you can get exactly 0 or exactly 1, right? At most 1. You could get none or exactly 1. So let's add these up then. So exactly 0, now exactly 0, that comes from this one right here. That's the 10. So we're going to get our 10 plus, and then exactly 1, that's going to come from this one, and this one. So what we're adding here is 3 plus 13 plus 23. And let's end it here with part E, can do only one of these activities. So only one. Well, only one, that's going to be like only cutting trees or only climbing poles or only splicing wire. So in D, We actually just counted that. I think this is E. Only one, that's going to be the 3 plus the 13 plus the 23. And that gives us, if I add right, I get a 36 out of that. And that, of course, is ridiculous. If I really add it right, I get 39. Right there is a 36, and 3 more is 39.